Hi everyone, today we want to talk about the standard deviation as a ruler. And so what we want to talk about is what's called a z-scores. And so by now you have learned about the normal distribution. The z-score is going to use the normal distribution. And so let's recall that the standard deviation is a ruler that can be used to measure how far a score is from the mean. And so what we can do is we can standardize a value from its original units to standardized units called a z-score. To find a z-score is going to depend on your population or if you're looking at a sample. And so when we look at a population, you're going to have some x minus the population mean divided by the population standard deviation. For a sample, you have some x minus the sample mean divided by the sample standard deviation. And so the concept is the same, but the formula is going to look differently depending if you're looking at a population or if you're looking at a sample. And so what we want to talk about is how we interpretate z-scores and also how to find them. When you're interpreting z-scores, a z-score for a certain value is basically the number of standard deviations above or below the mean. You can have a negative z-score, and a negative z-score is going to tell you that that data value is below the mean. And so a positive z-score will tell you that the data value is above the mean. And then the further the z-score is from the mean, the more unusual the z-score is going to be. And typically, the further the z-score is from the mean is going to be an outlier. But again, it's going to determine how far from the mean it is. And so let's look at finding a z-score, interpreting a z-score for a population. And so let's take an example. And so here, let's consider the heights and let them be in inches for adult males in the United States. They have a normal distribution with a mean of 70 inches and a standard deviation of 3 inches. And so we want to calculate and interpret the z-score for a height of 67 inches. And so why don't you pause the video, write down the mean, the standard deviation, and the height that we're looking at here, the 67 inches. Okay, hopefully you have those written down. And so, again, let's just look at what we were looking at. Here we were saying that x is normal with a mean of 70 inches and a standard deviation of 3 inches. Here we're looking at the population, and so z equals x minus the population mean divided by the population standard deviation. And so you could always make yourself a note right here. Here's your population mean. Here's your population standard deviation. And so you're going to have z equals. Remember our x, we was looking at x to be 67 inches. And so we're going to have 67 minus the population mean 70 divided by the population standard deviation 3. And so if you work that out, you should get -1 for your z-score. And so what is that telling us? What this is telling us is that this person's height is 1 standard deviation below the mean. And so that's what it means to be negative. You're that much below the mean in standard deviation units. And so here, again, this person's height is 1 standard deviation below the mean. And so let's take a look at another example. Here, we're going to look for a sample. And so let's say we have this data set right here. What we want to do is we want to calculate and interpret the z-score for when x is equal to 72. And so what you should do now is you're going to want to take your calculator out. You're going to want to type these numbers inside a list. Because here we're looking at a sample, we're not told the mean or standard deviation, and so we're going to have to find the standard deviation and the mean ourselves. And so pause the video, have your calculator out, start typing these numbers in the calculator, and make sure you have x equals 72 also on your paper. And so while you're doing that, and so here's my calculator here. And so here you want to go to Stat. You want to go to Edit. And as you can see right here, here are the numbers for my sample that we had in that data set. And so you want to go to Stat, go over to Calculate, hit Enter on the one variable stats. I had them in L1, and then you want to hit Enter. And so here, our sample mean x bar is 52.8. Our standard deviation, Sx, is equal to 28.56. And so write those two values down. You're going to use them when we find the z-score. And so let's find the z-score here. Let's write down what we found. We found that x bar was equal to 52.8. Sx was equal to 28.56. And let's just write down x was equal to 72. And so let's find the z-score for when x is equal to 72. Again, we're going to have z equals x minus the sample mean x bar divided by the sample standard deviation Sx. And so here we're going to have z equals our x, 72, minus the sample mean, 52.8, divided by the sample standard deviation, 28.56. And so if you work this out, you should get 0.67. And so what is that telling us? It's telling us that this score is 0.67 above the mean. And so again, if you're positive, you're that much above the mean in standard deviation units. And so this score is 0.67 standard deviations above the mean. And so another thing we can do with the z-scores is we can compare values, and this is a very useful thing to do. We can have a way with z-scores to compare values within the same data set or even in a different data set. And so they don't have to be in the same units when we look at them at their original units. One could be inches, one could be centimeters, but you can standardize them, find those z-scores, and then you can compare them. And so we have a nice neutral field once you get those into z-scores, and so it doesn't matter where these data values came from. And so let's just take an example of this. And so the mean for ACT scores is 20.8, and it has a standard deviation of 4.8. The mean for the SAT score is 1026 with a standard deviation of 209. And so let's say Joe scored a 27 on the ACT and Emily scored a 1318 on the SAT. What you want to do is calculate the z-scores and use them to determine who had the better score. Was it Joe or was it Emily? And so pause the video, write down the mean for the ACT, the standard deviation for the ACT, and do the same for the SAT. And you should write down what Joe scored and what Emily scored as well. Okay, hopefully you have those written down. And so let's just start with Joe. And so when we looked at Joe, he took the ACT. For the ACT, the mean was 20.8. And the standard deviation was 4.8. he scored a 27. And so there's going to be your x. And so what you're going to have here is z equals the 27, Joe's score, minus the mean, 20.8, divided by the standard deviation, 4.8. And so if you calculate this, you should get 1.29. And so there's Joe's z-score. Again, if we wanted to interpretate this, Joe's ACT score is 1.29 standard deviations above the mean. And so this is Joe's score. Now let's find Emily's. And so here when we look at Emily, she took the SAT. For the SAT, the mean is 1026. The standard deviation was 209. And Emily scored a 1318. And so there's your x. And so to find her z-score, you're going to have z equals 1318 minus the 1026, the mean, divided by the standard deviation, 209. And so if you work that out, you should get 1.397, and so you could round to 0.140. And so what this is telling us is Emily's SAT score is 1.4 standard deviations above the mean. And so who did better? Well, here we have Joe. His z-score was 1.29. Emily, she had a z-score as 1.40. And so when you compare z-scores from one another, the one who is further from the mean is going to be the person who performed better. And so here, Emily has the better z-score. It's further from the mean than what Joe's z-score is. And so here, Emily scored better. And so that's how you want to compare z-scores. When you have two different ones, whoever is further from the mean is going to be more unusual, and it's going to be the one who performed better. And so what we want to do is we want to take one more example with z-scores. And so here we're going to use the same mean and same standard deviation that we did in the last problem for ACT and SAT. Let's say Amy scored a 1287 on the SAT. Assuming that both the ACT and SAT measures the same thing, what score on the ACT is going to be equivalent to Amy's SAT score? And so we want to say, here's Amy's SAT score. If she had this score, what ACT score is going to be exactly the same? And so, again, we're going to have the same mean for the SAT, 1026, standard deviation 209. ACT, the mean is 20.8, the standard deviation is 4.8. And so pause the video, write down Amy's score for the SAT. Make sure you have the mean and standard deviation for both SAT and ACT. Okay, and so what you're going to do on this problem is you're going to take Amy, and she took the SAT, and so I'm going to just put a subscript there so we know what test we're looking at. You want to find her z-score. And so she scored a 1287 on the SAT, and so there's your x, minus the mean for the SAT, 1026, divided by the standard deviation, 209. And so here you should get a z-score as 1.25. Again, what this is saying is Amy SAT score is 1.25 standard deviations above the mean. And so what we're trying to figure out is what ACT score is going to have that same z-score right there of 1.25. And so what you're going to do is you're going to write down the z-score, 1.25, equal. What we're looking for is some x. We want to know what that x is for the ACT score. And so you're going to have x minus the ACT's mean, the 20.8, divided by the ACT standard deviation, 4.8. And so now this is going to become algebra. You want to find what is x. And so you want to get rid of the 4.8 on the bottom on the right-hand side. And so you're going to times both sides by 4.8. Remember, what you do on one side, you have to do on the other. And so 4.8 times 1.25 is 6, equal to x minus 20.8. You want to get x by itself, and so you want to add 20.8 to both sides. And so what you're going to get is 26.8 equal to x. And so you want to round up to the nearest whole number. And so what this is saying is the ACT score of 27 is going to be the same score as an SAT of 1287. They're exactly equivalent to one another. An SAT of 1287 is the same as an ACT of 27. And so that's another way that you can use these scores. And so why don't you just go back over these problems and just practice finding the z-scores.